Alright, so let's analyze this step function right here. So right away we can see from the equation over here that the a is 2, which means that the step height, so height will be equal to 2. We also see that the step length will be equal to 1 over b in the absolute values, and that's 1 over 1/3, which gives us 3, right, because our b is 1/3. We also know the h and k, which means the position of our first solid dot. So I'll call it our starting point, S, hk, and that happens to be 2, 1. So our h and k are here and here. So if I were to sketch this, I would be able to do it from here. So let's draw a sketch. It won't be the most precise one, but it'll be good enough. So I put my point at 2, 1. So 1, 2, 1. So here's 2, 1. It's my solid dot. My b is positive. If I go back to my function, I see that my b is positive, so it's going to be solid, open, solid, open, solid, open. And also the step length is 3, so starting at 2, 3, 4, 5, ending at 5 is my open circle. So here's my step. I now jump 2 to my next circle, go out another 3, open circle, etc. Jump 2 down, open circle, go 3 this way, close circle, and there we go. So there's our basic sketch for the graph. Next we have to ask a few questions like, what is the y-intercept? Y-intercept. Well, we can see from our graph that when I'm between -1 and 2, my graph is crossing the y-axis at -1. The next thing we can ask is, are there any zeros? Well, we see that the k is 1 and that the a is 2, and since k is not a multiple of a, since 1 is not a multiple of 2, then we can deduce that there are no zeros. So for zeros, I'm going to put the empty set. This function is increasing, so f of x, my function f of x, is increasing because since a times b is positive. So 2 times 1/3 is a positive number, so my function will be increasing. When is this function f of x greater than or equal to 0? F of x is greater than 0. I won't make it equal to 0 because there aren't any zeros. So f of x will be strictly greater than 0 when x belongs to the set, and here in red I'm going to draw all the positive, including this point here. That point happens to be our starting point that I wrote. It was 2, so it's going to be from 2 all the way to infinity. I have f of x greater than 0. F of x is strictly less than 0, so negative, when x belongs to. Now, it's going to be negative from here onwards towards negative infinity, but I have to make sure not to include this point here, because if I do, I would be taking a point in the positives, and I don't want positives, I want strictly negatives. So I'm going to say not including 2, I'm going to say negative infinity all the way to 2, not including it. And what else is there that we can analyze about this? I think that's pretty much it. Oh yes, one more thing, the domain and the range. A step function's domain is always all the real numbers, so x belongs to all the real numbers. And the range, we saw that we would write this as the set y such that y is equal to a multiple of our parameter a, which is 2, so 2 times a multiple plus our k, which was 1, where n is an element of the integers. So our multiple, what we're multiplying by, our letter n, has to be an integer. That way, whenever we choose any value of n, 2 times n plus 1 will always be in our range. Alright, so that's pretty much it. That's the analysis of a step function, a greatest integer function, and I guess there'll be more coming later.